This is a video on properties of exponents. We're going to apply multiple rules at some point, and here's an example where you really need to know pretty much all of the rules and use them kind of in a fluid way, knowing when they apply, when they don't, things like that. So there's really no exact way to start this. If you want to start on the inside and simplify those, that's fine. If you want to apply the powers right away, you can do that. It really doesn't matter. You got to find a way that works for you. And I like to kind of simplify the inside first. So that's where I'm going to start. And let's zoom way in on this first chunk here. First thing I notice is I've got a 2 and I've got a 6. And I know I'm going to be able to reduce that. That's just basically a fraction, right? So 2 goes into 6 3 times. So the 2 is going to just go away. It's going to become a 1, and the 6 is going to go away, and it's going to become a 3. So I'm just essentially dividing each of those by 2. I don't need the 1 anymore, so now I'm down to x squared y to the negative 3 over x 3x y to the positive 6. So that would be step 1 there. And it's a good thing because I know off the top of my head, I don't know if I know what 6 to the 5th is, but I do remember what 3 to the 5th is. So that's going to help me out a little bit there. I'm going to continue with this because I noticed that I can simplify even further. Okay, whenever you're ready to multiply your exponents by -5, you can. A negative is going to play an interesting part there. But I see an opportunity to reduce even further. I've got x squared, and I've got x to the 1. So I know that the x in the bottom is going to take one of the x's in the top away. So I'm going to have x. And then, personally, I like to move any negative exponent. I want to bring that down, have it join the y to the 6th in the bottom. So if I was looking at this as a singular step, it would kind of look like that. I canceled the x from the bottom with 1 from the top, and I've moved the y to the negative third to the bottom. And then I can combine these. So I get x over 3y to the 9th all to the -5. Not done with that, but I'm going to take a break from that one. I'm going to see if there's anything in this piece that I can kind of get rid of. And right off the bat, I see a y to the 0. I know that y to the 0 is equal to 1. I don't need it there. I also see an x here and an x here. These will cancel. And I see a z to the -5, which personally I want to move up. So when I simplify this one's a lot quicker. All right, the z goes from the bottom into the top, and the -5 becomes a +5. And then the 5, the coefficient in the denominator, stays right where it is. There's nothing else doing with that. And then I have the squared on the outside. So that makes the second piece a lot easier to look at. Let's zoom out a little bit, and I'm going to just drop that down right next to that. Z to the 5th over 5 squared. All right, so again, if you have a different way that you're doing this, that's fine. When I see a negative exponent on the outside of parentheses, I know a little trick here, and I really can just flip. Everything changes location. So this is going to become 3y to the 9th over x, and that takes the negative and basically applies it to that parenthesis, keeping the other one as is. Now I'm ready to raise everything to the 5th power in the first set of parentheses and the 2nd power in the second parentheses. So I'm going to do 3 to the 1 raised to the 5th, which is 3 to the 5th. I'm going to keep it like that for now. Y to the 9th to the 5th, I'm going to, why do I have an x there? I have y to the 45th, and then I have x to the 5th in the bottom. And on the other side, I have z to the 5th to the 2nd, so I'm multiplying the 5 in the exponent times the 2 to get z to the 10th. And then I'm squaring 5, or I'm multiplying the 1 in the exponent to get 5 squared, which we can jump right to and say 25. Now what's great about this is that there are no other z's, there are no other y's, there are no other x's. So really, all I have to do is keep the bottom as 25x to the 5th, keep the top in alphabetical order, and then determine what 3 to the 5th is, which is 243. There is my simplified version of my original problem. So all of this simplifies down into that. So that's just one example of applying multiple rules simultaneously.